Hello everyone, welcome to Java Sessions. So in today's tutorial video, we'll be doing anagrams. That is to say, we're gonna write an algorithm that will tell us how many things we are supposed to move in order to make two strings in an anagram. So before I get into that, let me just say that I'm aware that I've been absent lately. So what I've been working on was as you know, Java Session is actually a subsection of Omega Technologies, which is something that I've discussed I think in previous videos. But then as you know that I had free time during this holiday, so I decided to work on the three other sections, which is tutoring live and software requests and also coding competitions. So I've been working on those three. So making anagrams. So two strings are anagrams if you can rearrange their characters to make them similar. Actually, let me just use the generate to explain what I'm talking about. For example, if you have ADF and FDA, these two strings are anagrams because let's say this is S1 string 1 and then make this string 2, then you can make string 2 equal to string A if you can arrange their string 2's characters. Say put A first, say S2, you can just say let's just say S2 add character 2, and then you also making it equals to S2 add character 1, and then S2 add character 0. Now you can see in programming language, if you can change S2 to be equal to this, it will be equal to S1. Hence we are saying they are anagrams because they have the same characters. So what this algorithm is about is not to detect whether two strings are anagrams or not, but whether to tell how many characters are we supposed to remove from these strings in order to make them anagrams. That is to say, what characters are unnecessary in both of the two strings for them in order to be anagrams. So they also gave an example here. Say Alice decides on an encryption scheme involving two large strings where encryption is dependent on minimum number of character deletions required to make two strings anagrams. Can you help me find this number? So that's exactly what we're going to do. So they say given two strings A, B that may or may not be the same length. This is the keyword. I'm going to explain it once we go to review my algorithm. Determine the minimum number of character deletions required to make A and B anagrams. Any characters can be deleted in either the strings. So you can delete any character from the strings. You can they can or cannot be two the same length. That's the very important outline I'll say out there, because it's also what's going to make the algorithm a bit difficult. So I urge you right now to actually just pause the video and try to solve it on your own, and just you'll get back to the video once you're done and let me know on the comment sections if you had a better solution than mine or you had a worse solution. I don't care. Let's just discuss what's the better optimization of this algorithm. So here's the basic input of A and B. You will understand how a scanner works. So let me just get into the core of things, as to say the actual function that makes anagrams. So this function will return an integer, and I made it static because I'm calling it inside a static function, which is the main function, as you can see. So anyways, actually here the idea that I utilized was the fact that in an English language you have 26 characters. So we have A, B, C till Z. So in order to work on the fact that I didn't want to make my algorithm really slow, let's say go through each and every string in order to check the containment of whether a particular character is containing some string and not in other string. I decided to actually loop through 26 characters and check in both. That is to say, make the characters be the driving force of what we're going to check, not another string be the driving force of another string, which is what the first algorithm actually did. So here what I did was say if it's containing both in both characters, I'm going to tell how many times is it containing B in A and how many times is it containing B. So if you had this, then that means you also have to remove it here in order to make this thing an anagram. Not the fact that that's because it's containing both, then we don't have to remove it. If it's contained twice here and once here, we still have to remove. And then here I actually use the same logic here as the same. If it's containing A, then I have to remove it twice. And then here, if it's containing A, then I have to calculate how many removals are there if you're going to remove that character from A. And then I use the same thing here in B, and then I loop from A, B till Z. And that's my time, ladies and gentlemen. Please leave on the comment section if you have any questions about what I just explained. I'll also try to actually no, I won't do that. This is pretty much self-explanatory. If it's containing B and not containing A, then I have to calculate how many removals are necessary. By doing that, I'm going to get the length of B and then minus B when that character is not there, and then same thing here. And the reason that I multiplied by -1 here, that's to change it into its positive counterpart, is because it's possible that A might be lesser than B. So here it doesn't matter whether I say B minus A or A minus B, but the fact remains I don't want removers to decrease, I want the removers to increase. So in the case that A count is less than B count, I don't want it to end up decreasing the number of removers or ending up giving us a negative number of removers. So let's do a test real quick. So I'm going to use the test cases that they gave us here. That's say CDE, and then the other one was ABC. So ABC, and then we have to remove 4 characters in order to make these 2 anagrams. And that is actually true because in order to make them anagrams, you have to remove DE in A, and you're gonna have to remove AB in B, which is the same answer that they got here. So thank you, ladies and gentlemen. If you like this video, please leave a like, please subscribe, leave a comment if you have any questions. Share the video to your friends and your friends' friends and your friends' friends. Just say to anyone you know, and let the person that you know to share the video on that day so that you can